going to continue on working on equivalent ratios. A lot of the work we're going to do today has to center around making sure you guys understand this ratio constant concept. We're also going to take a chance later on to do a activity to get you guys up out of your seats and around the room. We'll call it that around the room ratios, where we're actually going to just focus and see if you guys can look at a picture and put those ratios together. So let's start with the text, marking the text in our textbook. So everybody should be on page 13 right now. And on page 13, the morning announcement said that 2 out of every 7 6th grade students in the school have an overdue library book. Jasmine said that would mean 24 of us have overdue books. Grace argued, no way, that is way too high. So how can you determine who is right? There's our task. That's what we need to do. So let's start it with a tape diagram. So in our tape diagram, what is it going to look like? How many boxes are going to go on top? Wesley? On top? What's the first number that was listed? 2. So the 2 is going to go on top. And what does that 2 represent? No, what are those 2? What do we know about them? Sophie? Overdue books. So I'm going to use an O, which is always dangerous because it looks like a 0. But that's part of why we define our variables, right? So O is the overdue books. Okay? And then what is my second one? What's the second part of my ratio? Rosena? 7. And what does that 7 represent? What about students? Do what? JJ? All the 6th graders. So I'm going to use T for total 6th graders. So the total number of 6th graders. Okay? Now, someone already said that, remember, we always have to have that third piece of information, right? So what is that third piece of information? What about 24? So where does that go? That goes with the overdue. So I know that those 2 boxes gives me 24. So at this point, can I now find my ratio constant? What is it? 12. Is there anybody who does not see that? Good. Thank you for being honest, Sylvia. Okay, so I have 2 boxes that need to equal up to 24, right? So what would go in each box that I put 2 of them together to get 24? You see it? Okay. So another way to think of it is all I do is I take the 24, I'm going to divide it to 2 boxes to see what goes in each box. That's going to be 1, 2, so 12 goes in each box. Now here is the beauty of our tape diagrams and ratio constants. Once I have my ratio constant, now what do I do with it? Go ahead. Awesome. Well done. Put it in every box. So now all the boxes on the bottom get a 12. So I now have 7 boxes of 12. So what are we looking at for the total students? Sean? Total is 84. So are we done? What do we need to do? Emma? Okay, so what is our answer? What was, let me rephrase that. What was the question? So is 84 the answer to that? No. We're going to have some fun. Well, I don't know. Wesley might ruin this for us. Wesley? Awesome. Why is Jasmine right? Leslie, why is Jasmine right? Leslie seems to be struggling with it. Can someone help him? Aaron? Do what? Oh, that was an accidental? That shot up so fast, that's hard to believe that was accidental. You're still very good at math. Madison? The tape diagram? Good. So how does that make Jasmine right? Well, actually, let's go back to the question. How do we know, how can we determine who is right? Sean? Good. Okay. So again, how can I determine who is right? Nora? Does looking at the tape diagram give us the answer? Do you guys really want to know why you're all struggling so much? JJ? Sean just did that. Sean did a great job, for those of you who couldn't hear it at home, explaining. Yeah, that 2 gave us the 12 racial constant, which meant there were 84 total students. So, yeah, same thing. You guys are both all caught on the fact that Jasmine gave us this information. Anna?
It's telling about out of every student in 6th grade, like 7 for each.
Okay.
Each for all of them, and it's talking about the whole school, which means it's going to have a big number of it, which means like if it's 2 out of every 7, it would still be big because if it were actually 84, it would be able to be it was divisible by 7, which would mean it's still a big number.
Did you guys hear what she said?
No.
She actually said it. I don't think she even realized she said.
I don't think that's what she meant, though.
I don't think she meant it, but she actually said exactly what the issue is. How many of you listened closely to what Ayana had just said? So what was the key phrase that she said that can help us determine who is right? Leslie, did you pick it up? But what did she say? She added a word before the 84. Emma? No. Sean? No. She said, if it is 84. What is it we don't know? What is it we don't know that would help us determine who is right? Is that you, Ava?
Yeah.
We don't know how many 6th graders there are, right?
Exactly.
So how would we determine who is right? What's the answer to that question? We can. Not find. if we know how many sixth graders there are. So how can you determine who is right? By knowing how many sixth graders there are. Once we know how many there are, then we could determine who is correct. If there are 84 sixth graders, is Jasmine correct? Emily? Or Miss Witt?
Mr. Moore, if I know the answers but I don't write it down and I don't write every single word, or if I don't put 12 in a box, or I don't write the answer, or I don't write O equals, or I don't write T equals, will I get full credit on the quizzes and tests?
Not on the quizzes and tests, you
But
won't.
what if they're right?
Doesn't matter. If you don't show the work on the quizzes and tests, you don't get full credit.
So you're telling me if I write exactly what you're writing on that board and I do it correctly, I will get 100%.
Absolutely.
Thank you, Mr. Moore.
Thank you, Miss Witt. Apparently, she has been looking at people's books as she's been wandering around, and some of you are still not writing down what we write on the boards. Please do so. It will definitely help you on these quizzes and tests. Okay, so back to the point we were making. If there are exactly 84 students, is Jasmine correct? Yes. So Grace said what? Grace said, no way, it's way too high. So if there are more students than 84, is Grace correct? If there's, she said that 24 is too high. So if there's actually more students, then that number would be less. So if there's more students, that would mean that Grace is correct. That 24 is too high. If there are less than 84 students, it actually means that they're both wrong. But this whole thing, the whole thing centers around, they don't tell us how many students there were. So we can't really tell who is correct. We can do all of this math and we can figure all this out. But if we don't pay attention to the question, guys, you're going to get the wrong answer. You guys remember day three of class this year? We did that directions test. How many of you did like the entire page? Yours was priceless, Madison. I will never forget yours. That was awesome. JJ's was actually really good too, but yours was by far the best. Questions? Yes. Deanna? Question? You just had your hand up. Is it Avi? Question? No? You guys are like just raising your hands for nothing? Wow, all these stretchers. Okay. We're going to go ahead and do this one piece together as well. So decide whether or not each of the following pairs of ratios is equivalent. If the ratios are not equivalent, find a ratio that is equivalent to the first ratio. If the ratios are equivalent, identify the non-zero number C, or in other words, your ratio constant. That could be used to multiply each number of the first ratio in order to get the numbers for the second ratio. So we're going to do these first two together just to give you an idea of what it is we're looking at. Okay? All it's saying is compare these two ratios. Find the ratio constant. Once you've got the ratio constant, tell me, are they actually equivalent or not? In other words, do I use the same ratio constant for both numbers? So we'll start with 6 to 11. So my top number of boxes is, for my tape diagram, 6. My bottom line of boxes gets 11. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, we don't have to label this because all we're doing is comparing these two numbers. But I do know the 6 becomes 42. So that gives me a ratio constant of how many boxes of 6? 6 boxes of what number gets me 42? Jasmine? 7. So my ratio constant is 7. So I now have 11 boxes of 7. That means my second number is, Emma? 77. What number did they say? So are those ratios equivalent? No, they're not. Because if they were equivalent, then my second number would have been an 88. But we've used our ratio constant, and we now know that a actual equivalent ratio would be what? 42 to 77. Does that make sense? Caveat, I don't like the second one very much, but it does help show why 0 is okay in the first number, but not the second. So tape diagrams on this are a little bit more difficult to do, but I have 0 boxes on top. Underneath I have 5 boxes. Okay? So in my 0 boxes, what number would I put in to get 0? I had literally put any number. So we'll have to look at our second one. How do I go from 5 to 20? What number would go in for my ratio constant? 4. So I put a 4 in every box. So I now have 0 boxes of 0 and 0 boxes of 4. Is that equivalent to our 5 and 4? Yeah, so what's our ratio constant? What number did we get to do multiply by both? 4. So 4 times 0, seems to be a dead spot right there. 4 times 0 is still 0. 5 times 4 is 20. So that is an equivalent ratio. Does that make sense? Okay? And that is, again, why it's okay to have the first number as 0, but we can't do that second one. I can't take something and make it into nothing. Okay, I want you guys to turn the page real quick. I'm just tapping the board. You're not talking to me again, Miss McShann? I know. Actually, this is true. Okay, I want you to draw a line about halfway down the page. Yep. Okay. Underneath that line, I want you to write this. So we're going to do 2 to 3, 16 to 18. Then I also want you to write 4 to 7.
On the back of the page, you were working on the bottom half.
28 to 49.
Divide your paper in half and work on the bottom.
So you turn the page to exercise 2, draw a line halfway down. Right under that line, I want you to write these ratios. So we're going to do the same thing we did on the previous page. I want you to compare those ratios and determine, are they equivalent? If so, what is my ratio constant? If they're not equivalent, give me an equivalent ratio to the first set of numbers. Whoa, I don't know why it did that. Miss McShann's working her voodoo magic again. And those Louisiana people, you got to watch out for that voodoo. It's dangerous. Questions? Voodoo. Madison. So you're taking 2 to 3 and 16 to 18, just like we did on that previous page together. Tell me, is there a ratio constant that gets me to those? In other words, are they equivalent? If they are not equivalent, give me an equivalent ratio to 2 to 3. Okay? So we'll give you guys about 5 minutes. Work together at the table if you want. Okay, our first one. We're comparing 2 to 3 to 16 to 18. How many of you felt those were equivalent? Raise your hand. Good. They were not. So we do our tape diagram. We've got 2 to 3. To get to 16, I would have a ratio constant of 8, which means my second one would have been 24. So, no, they're not equivalent. Actually, like someone who did that, they're not equivalent. An equivalent ratio would have been 16 to 24. Make sense?
And you should have that written out in words, even though he didn't write it in words. I told him to write the sentence from the previous page.
Oh, yeah, okay. Yeah, if you wrote the sentence over, that's great. 4 to 7, we have 4 on top and 7 on the bottom. So on this one, how do I go from 4 to 28? What's my ratio constant? So that gives me a ratio constant of 7. So I continue my ratio constant. 7 sevens gives me 49. So they are equivalent. So they are equivalent. The ratio constant is 7. That's what went in every box to make them equal. Make sense? Any questions? How did you guys do on that? Let's do a quick thumb meter. Thumbs up, thumbs down. Oh, good. Looks like most of you did well on that. Perfect. Okay, let's come back up to this problem. On this problem, in a bag of mixed walnuts and cashews, the ratio of the number of walnuts to the number of cashews is 5 to 6. Determine the number of walnuts that are in the bag if there are 54 cashews. So there's our first pass. We need to determine the number of walnuts. Use a tape diagram to support your work. There's a direction, so we'll box that. Justify your answer by showing that the new ratio you created of the number of walnuts to the number of cashews is equivalent to 5 to 6. So we've got 3 different things that we need to do, correct? I need to determine the number of cashews, I need to use a tape diagram, and I need to justify my answer. Questions? We'll let you work together as a table. You've got 5 minutes. Go. Okay, this one is set up relatively easily. They gave us the initial ratio, 5 to 6. So my tape diagram, I have 5 on the top, 6 on the bottom. On the top, I start with number of walnuts to number of cashews. So that means the top is walnuts, bottom is cashews. Please don't forget to identify your variables. That was a very common mistake as I was looking at my students' homework. I'm not sure how Ms. McShann's slide did.
Sorry?
Identifying their variables.
Yeah, we did that.
Okay? So make sure you're doing that every time, guys. It helps you understand up front what everything is. That makes that last piece really easy. They now said I have 54 cashews. So if I have labeled my diagram, it's very easy to see that that goes where? Top or bottom? Bottom, because that's where the cashews is. So I know that is 54. So how many, what's my ratio constant? What goes in each box? I get 6 numbers for 54. Maddie? 9. So I have a ratio constant of 9. Guys, stop the chatter back there. Once I have my ratio constant of 9, every box gets my ratio constant. So now I have 5 boxes of 9. That means I had how many walnuts? Okay? So this was our first part. It said determine the number of walnuts. So there are 45 walnuts. Was that the only thing that I had to do? No, there were 2 other things, right? One, I did the tape diagram. Did we use a tape diagram? So have I done that? Our third one, justify by showing that the new one is equivalent. Have I done that? Technically I did by my ratio constant in there, but let's use because I want you guys to get used to this and have an example on the video. Here is how we do this using the definition of equivalent ratios. So if you look at the definition that we gave you last class period, it's actually on the next page, it says that they are going to simplify to the same form. So what I'm going to do is start this ratio at 45 to 54. What can I simplify both those numbers by? I can divide them both by 9. So if I divide them both by 9, I get, geez, my marker's going all over the place, 5 to 6. What was my initial ratio? 5 to 6. So they are equivalent. By the definition of equivalent ratios, I have the same ratio. Questions? Okay. Actually, it's on the opposing page for you guys, here is your homework. Only 3 problems. So this should be really, really simple. Couple things to point out. Problem number 1 says what? Use diagrams or the description of equivalent ratios. So I have 2 choices. Personally, I recommend, guys, use the tape diagrams. I would like you to get used to these. It actually is a very useful tool that we'll be using for the next 2 modules, at least, to show that 2 to 3, 4 to 6, and 8 to 12 are equivalent. If you want, because it gives you the option, you can just show that 4 to 6 and 8 to 12 both simplify to 2 to 3, or you can just do a quick tape diagram and you use your ratio constant to show that they're equivalent. Part number 2 actually doesn't give you an option. It's going to make you do both. So, part A, you have to use a tape diagram. Part B, you have to use the definition of equivalent ratios. In other words, turn these both into fractions, show that 12 over 32 simplifies to 3 over 8 by showing me what you would divide by. Okay? I'm going to give you guys a heads up that the other classes don't get, because this is the video, and I was trying to throw a little extra in there to get you guys to watch the video. But the ratio of Isabella's money to Shane's money is 3 to 11. If Isabella has $33, how much money do Shane and Isabella have together? There is our question. What is the big piece in this? Lasena? Once I have figured out what each of them have, I need to combine it, because it asks what they have together. Also, it says what? Use diagrams. So do I have to have a tape diagram? Yes, because it told me in the directions I had to. Okay? So use diagrams to illustrate your answer. That is a direction. That one should be boxed if you're marking your text. But that should allow you guys to be really successful on this homework. Yes, Sean? Nothing? Okay. Okay, right now,